This video will be concerned with product design and process development. And within the context of process development, we're going to look at process selection. Product design considerations must include the process. Looking at product designs independent of the process is not good practice. The process is what will incur the costs. It's what will engage the management. It will occupy the staff right throughout the organization. The process is what the business does in many respects. So having agreed the design for the product, the process is what must be implemented, put in place and implemented. So the process design should be aware, the product design should be aware of the process requirements. Now there's a difference between intermittent and repetitive operations. Intermittent, as the name suggests, are once in a while, whereas repetitive operations are ones which occur on a continuous basis. So with intermittent, we're looking at the amount of product volume produced. We're looking at the total amount produced and how it's produced. It may be produced from time to time as required. And we should also look at the repetitive situation, which is more to dealing with standardization and continuous production. It's repetitive operations. So the operations really go with the products. If the products are intermittent in demand, they tend to have intermittent processes which are brought into play to produce the product which has an intermittent demand, a demand which crops up every once in a while. Repetitive operations are associated with products which are produced on a repetitive basis. So really the type of product and the type of production determines the type of operations that are going to be required. So let's deal with intermittent, or if you like, infrequent and repetitive operations. Well, we can contrast the two in terms of the decisions that have to be made. So for example, when we're dealing with product variety, with intermittent operations, we have many varieties. It's produced from time to time. But with repetitive operations, we have very few product designs. It's repetitive, it's running all the time. And therefore, there are very few different styles in production. So this means that repetitive operations will probably have less technical issues. It'll have a more straightforward production system. Intermittent production will need switching over machines perhaps from one type of production to the next. It's intermittent. It happens once in a while. The degree of standardization, well, with intermittent operations, there's very few degrees of standardization. The products tend to be varied. There are few of them produced. They're intermittent production. Whereas with repetitive operations, there's a high degree of standardization. The organization of resources, well, normally for intermittent operations, these are grouped by function. Whereas for repetitive operations, it's line production. Line production means it's running continuously and the resources are set up and they are dedicated to the production of that item. It's a continuous production. Whereas with intermittent, the resources are grouped by function and delivered by function, what is required. The factors driving production, well, with intermittent operations, it's customer orders. Customer orders come in, the company tools up and produces that item. With repetitive operations, it's forecast future demand. The machines are running continuously, making this item. So a lot of it will go into stock. It will go into stock in the stores, in warehouses, in wholesalers, in retailers. It depends on where the market is, but the chances are it's produced in advance of demand. The type of equipment, well, for intermittent operations, it's general purpose. Just whatever is available and is brought into play to make those intermittent items. With repetitive operations, it may be highly specialized. The machines may be customized to run smoothly and run in an automated sense because it's continuous production. So the machines may be highly specialized machines. The degree of automation, well, very low with intermittent operations because it's not worthwhile automating the machines. The items only come up for production once in a while. With repetitive operations, there's a high degree of automation. If it's possible, the lines in which the items are produced should be automated. The machines should be programmed, if possible, to produce certain functions. There should be specialist designs on the machines as well to help them produce at a high volume rate. The throughput time, well, it's low for intermittent operations. Intermittent operations may have to run through certain processes and be taken off the machines, moved back onto different machines and be moved around between one part of the shop floor and the next until they are completed. With repetitive operations, the machines are dedicated to its production. It may be a line production where raw materials are entered at one end and the finished product comes off at the other end, and the product is moving continuously down the line. So there's a high degree of throughput with repetitive operations. Work in progress, well, generally speaking, with intermittent operations, there's more work in progress. The work in progress sometimes happens because the work is put onto machines and partially completed, then put back into the stores while other more pressing jobs are completed by the same machines, then brought back from the stores and completed. So it's work in progress. There's more of it around. It's intermittent operations. It only happens once in a while and it's not continuous. With repetitive operations, there's less work in progress. It's continuing. It's been processed all the time. So there's less work in progress to be seen. Now the process selection types. Well, process selection types can be project processes, make a one-at-a-time product exactly to the customer specifications. So it's looking at a particular project and dealing with that one project, and the one project has been specified by the customer. They say exactly what they want. For example, if a customer wants a suit of clothes, they want the suit made to a particular style with a particular fabric. The customer is making the specification. Batch processes, small quantities of products in groups or batches based on customer orders or specifications. Again, maybe instead of having one item, the customer has 3 or 4. So there's a batch produced. The items may be essentially the same, but they're produced in batch. Line processes, large quantities of standard products. Much mass production techniques can be seen in products in the household. Biscuits and confectionery. These are normally produced in enormous quantities in line processes. Raw materials go in one end, the finished product comes off the other end. And it could be continuous process, very high volumes of a fully standard product. So very high volumes. As I said, the raw materials go in one end, the product comes off the other, and it's all the functions that are required are done. Most of them done automatically The machines are customized to do this. They are perhaps programmed and computer controlled and very technical. But it means that production is continuous. So we have different types of processes we can imagine. Project process, batch, line, and continuous. Now the underlying process relationship between volume and standardization continuum. Well, if we can imagine it as a little chart like this, we could have product standardization on the vertical axis, very low standardization at the top and very high at the bottom. And we have the volume of output along the horizontal axis, ranging from 0 to a very high volume on the right hand side. Now if we insert in project process, customized projects, we've got very low standardization. These projects are specified by the customer, so it's customized output. And there could also be batch processes, which is essentially looking at customized processes, and instead of making one, making maybe 10 or 20 of them, or whatever. They're making some small quantity. So it's a batch process. And these are intermittent operations. These only happen when the customer places the orders. So it's low volume and it's low standardization. For repetitive operations, we have line process and continuous processes. We have assembly lines, where the name line process comes from, of course. We have line processes, assembly processes, where items are assembled and produced along a continuous line. And we have continuous processes, for example, electricity generation. It's continuous, it's all the time, it's repetitive. So there's high volume for these and very high standardization, very high degrees of standardization. All the items are essentially the same. So for electricity, all units of electricity are the same. So that's a way of looking at the difference between intermittent and repetitive operations, and looking at this relationship between standardization and volume. Now, process selection considerations. Well, process selection is based on 5 considerations. The type of process ranges from intermittent to repetitive or continuous. So it's the type of process that's the first consideration when thinking about process selection. What's the type of process that's under consideration? What's the degree of vertical integration? Now, vertical integration in this sense means what's the relationship between, say, raw materials and the acquisition of raw materials and production? And what's the relationship between production and distribution and the retail outlets who perhaps sell the product? So the process selection will depend on the degree of vertical integration, how close the company can work with its suppliers to secure supplies of raw materials and components as and when required, or does it have to buy and hold the items in stock? And can it simply deliver the finished product to warehouses or wholesalers or whoever? Does it have that sort of relationship? Or does it have to put the finished product back into the stores and wait for orders to come in? So the degree of vertical integration, moving closer to the market, if you like, from raw materials closer to the customer, the degree to which that is integrated will determine the type of process that should be used. It should also depend on the flexibility of resources. Some resources can be switched over easily to produce other items. Perhaps some machinery just may require adding an extra feature or subtracting an extra feature, and a new process can be brought into play. So it depends. The type of process selected may depend on the flexibility of the machinery, the flexibility of the personnel, their skills, the design of the production process itself. And the mix between capital and human resources. The people who run the machines should have the skills and the competencies to run the machines effectively, but they should also be able to deal with issues as they arise. They should be able to switch over into different processes if required, if the machines permit this. So the flexibility and the ability, of the workers operating the machines is important. And the blend between how much work the workers do and how much the machines does is also critical. So the final one is the degree of customer contact. Processes may be determined by customer contact. The customers may specify how they want the items produced. Perhaps they want the items produced in a very slow and meticulous form with a lot of intervention and inspection, or maybe they're quite happy to see it run through very fast through the system and be produced to good quality, but nonetheless move fast through the system. It depends on what the customers want and what the company can facilitate. The process design tools. Well, we have multi-stage processes. We got stage 1, stage 2, stage 3, so the item must move through the various stages to completion. We also have multi-stage with buffers. So stage 1 is completed, then it moves into inventory. Then it comes out of inventory and into stage 2. So it's multi-stage with buffers. The buffer here is the stock held in the stores. So stage 1 produces, then it goes to the stores, then it comes out of the stores and on to stage 2. We have parallel stages, different products. For example, stage 1 makes finished products and stage 2 makes finished products. So we have parallel production. We have different parts of the organization making different finished products. And we have parallel with the same product. We have stage 1 and stage 2 both making the finished product. Now, designing processes. Well, process design tools include process flow analysis, trying to work out the process flows and how many is going to be made in a particular time period and what are the resources required, and looking at the overall tooling required to make the item and looking at the process flow that may result from good design, from being able to link stores to production, personnel, machine maintenance, all the way through to the end. There's also a process flow chart which may be used, which indicates where the job has got to, how many have been produced, how many are in production, how many are waiting to be produced, what's the time taken, what issues have been confronted, how there have been breakdowns on the system. So a flow chart may be useful as a way of monitoring all of this. Design considerations. Well, these include making to stock strategy. So it's a design consideration. Should the item be made and then put into stock? Should it be put into stock and then the components taken back out and assembled to order? So resources are not used initially to assemble the product and then put it into the stores. Simply the various components are put into the stores and it's assembled when an order is received. That's a possibility. Or it could be to make to order. Wait for the customer to place an order and then make it. Very similar to JIT, just in time. So wait for the order and then make. That's a possibility. So there are different ways of looking at the processes. Now the metrics or the measurements associated with process performance. Well, first of all, measurement of different process characteristics that tell us how a process is performing. That's what we mean by metrics. It's the measurement of different process characteristics that tells us how the process is performing. So it's looking at throughput, it's looking at the volume going through, it's looking at issues associated with production, it's looking at breakdowns, it's looking at personnel, it's looking at measuring, where possible, the performance of the line, or if it's continuous production, the continuous production facility. So it's constantly monitoring the performance of the production system. Determining if a process is functioning properly is required. Management needs this to know if it should intervene or not. Determining or determination requires measuring performance. Measuring performance does require effort, it does require resources, it requires accuracy and a desire to pick up proper results being defined as accurate results, ones that can be used. So it's important for management to have a commitment to measuring performance, even though they may not be able to divide up the performance of different components in the processes. As I said earlier in this session, it may be difficult to separate out the contribution of the machine from the contribution of the operator. The operator turns on the machine and makes sure the machine is working, but the speed at which the machine works is determined by its capacity. And if the machine is improved and works faster, does that mean that the operator is working faster? Or does it mean the machine is working faster? So sometimes measuring performance is complicated, but it should be a determination on the part of management to measure. Having said that, it's important to have information, providing it's not misleading information. Information facilitates good decision making. So different measures we could use and the meanings. Well, throughput time. It's the average time it takes for a product to move through the system. We call it the throughput time. How long does a product from start to finish, how long does it take? The process velocity, it measures wasted time in the system. It's the throughput time divided by the value added time. For example, let's say work out the process velocity. Say it takes 2 weeks, 3 days, 4 hours a day to make something, or to make some batch. And let's say we got 5 hours value added time in a day. So we have 4.8, really 4.8 days effectively to make this. Now the lower it is, the lower that figure is, the better it is. So it's a way of just getting a benchmark and seeing how particular parts are functioning. If it's 4.8 this week, was it 4.6 last week, or was it 5.1? So there's an indication of how well the section is doing. Productivity is measured by output over input, and as I said several times now, it's very difficult to calculate what the inputs are. The inputs may be just the machines, it may be the machines and the workers, but it may be the machines, the workers and the building, because the machine is in the building. It may be the machine, the workers and the accounts section who pay the operator and paid for the machine. And without them it wouldn't happen. So what's their contribution? So measuring inputs is very complicated. So there'd have to be an agreement on the part of management as to which input they're measuring. Outputs may be quite easily identified, perhaps. It's the product coming off the end. But the inputs, now those may be difficult to decide. But having said that, productivity is a very popular measure to use. It's a very simple one. When you look at the equation, it's equal to output divided by input. Very straightforward. We also have utilization, which is the proportion of time a resource is used. So you take the total time that the resource is available and divide it, take the time it's used, the resource is used, and divide it by the time it's available. So if the resource is available for 5 days and it's used 1 day, then the utilization is 1/5, is 20%. So utilization may be another index that could be used, another part of the metrics for assessing performance. And efficiency measures performance relative to a standard. So we have the actual output over some standard output, which measures the efficiency. We look at the actual output from a department in terms of number of items produced, and we compare it to what the management consider it should have been, which is an indicator of the efficiency of the department. It may also, of course, be an indicator of management setting the actual figure wrongly at the start. But with experience and with good management, standard figures should not be that far off. They should be realistic. Linking product design and process selection. Well, product design and process selection are directly linked. The type of product selected defines the type of operation required. So the design of the product and the process selection are linked. The more complex the design, perhaps more processes are required. The more straightforward the design, the easier the processes can be. The type of product selected defines the operation required. The type of operation available defines broader organizational aspects, such as the equipment required. So the type of organization available defines the broader organizational aspects, the equipment, the facility arrangement, and the organizational structure. So really, the organization must look to the product design, because that's an indicator of the type of processes that they will need to undertake. And of course, the type of processes will determine the type of equipment that the organization needs. It also determines the type of facility it requires, and the whole production system will partially determine, if not entirely determine, the organizational structure of the business. So the product design is critically important, because this is where everything flows from. It flows from there that the processes will be determined by the design. The processes will require the machines, the operators, and the equipment, the facilities, and so on. So it all flows back to the product design. Product design decisions. Well, intermittent and repetitive operations typically focus on producing products in different stages of the product life cycle. So intermittent products, more specialized products, and repetitive operations, typically these focus on different parts of the product life cycle. If it's a small amount of product that's made, it may be used as a tester at the early stages of the product life cycle, introducing the product. As the product becomes more popular, it moves into the maturity stage. At that stage in the product life cycle, it may be producing lots of this output. It may be mass producing this output. And then it goes into decline when the mass production is cut back, it's scaled back, perhaps new products are now introduced behind it, but it's cut back and it moves back to smaller amounts of production, smaller, and eventually it'll become intermittent as the market declines completely. So we can imagine with the product life cycle, small amounts of the product coming onto the market, it becomes popular, it becomes mass produced as it moves into the maturity stage, and then goes into the decline stage. Mass production is cut back and the item is still produced but not in the same volume, and eventually it's in decline, completely in decline. In that stage it may just become intermittent production, just to meet specialist orders and perhaps still purchased by some people for whatever reason. Intermittent is best for early in the product life cycle. Repetitive is better for later when demand is more predictable. So as I said, it may be that the organization will start off with intermittent production, small amounts of production, testing the market. If it becomes successful, it'll move into much more repetitive, much more continuous production, and later on, when the product starts to decline, it'll move back towards intermittent. Competitive priorities. Well, decisions of how a company will compete in the marketplace. These are important. Within the strategic planning framework, there should be something on competitor analysis and looking at competition and looking at how the company can position itself best to take on competition. Intermittent operations are typically less competitive on cost than repetitive ones. So the company must make decisions as to whether it's going to mass produce the item, in which case it's much cheaper, specialist machinery, continuous production, much cheaper than intermittent, where production will have to be switched over and gone into stores to hold in the stores and taken back and completed at a later stage. That's costly. So looking at competitors and looking at the prices they charge, this may partially determine the type of process that the company will undertake. Think of off the rack versus custom tailoring in the clothing sector. Off the rack, much more expensive, custom, cheaper. That's all we're going to deal with in this session. It's a long class. I recommend strongly that you go back over it, use the stop and start buttons and make your own notes, do some additional reading. It's important to have a good understanding of the relationship between product design and process development, because one really determines the other, and understand the differences between the types of production system that will lead to different types of output, more specialist output or more batch, more continuous type of production. So please go back over the video, make your own notes and pad out your notes and try to understand the various concepts that are mentioned in here. But that's all we're going to deal with, as I said, so let's leave it at that and say thank you for watching.